Hey everyone, so we are going to create our situation of a line, and then we are going to have a point that is not on the line. And I'm going to use this in order to come up with the situations that we've been working with today. So the situations we have been working with are two parallel lines cut by oops, I don't want to do that. Two parallel lines cut by a transversal. So I have that line AB. I put that point C there, and then I'm going to use my parallel line tool to have a line that is parallel to that one. It's going to go through right there. And as always, I'm going to put points on my diagram. So then I have everything labeled as I need to. And I'm going to take this one step further, and I am going to find the angle measures of each of these angles. So this is a little tool that this program is letting us use. So when I do that for each angle, when I do it for each angle there, then I am able to find the degree measures. And these aren't perfect. They're not nice round numbers, but we have those numbers there. And now I'm going to find the angle measures on this new spot that I created over there. So I have each of those angle measures. And what I did is I just created two parallel lines that were cut by a transversal. And I know they're parallel because I use this computer program to tell me that they were parallel. So now we can look at some very interesting angle relationships. And we have, for example, let me pull up here. Excellent. This angle and that angle, those angles are alternate interior angles because they're inside of our two. Let me color code these a little bit. They are inside of the two lines, the two parallel lines. Ooh, I'm definitely going to have to clean that up. They're inside the two parallel lines, and they're on alternate sides of our transversal of the line that is cutting through them. So they're alternate interior angles, and look at that. They are the same degree measure. If we wanted to look at a different set of alternate interior angles, we could look at this angle here, that 59.6 degrees, and the alternate interior angle, so it's inside the two parallel lines, and it's on the alternate side of the transversal. Well, that is also 59.6. So alternate interior angles have the same measure. Alternate interior angles are congruent. Well, let's look at a different relationship then. I'm going to pick a slightly, there we go, that's a better color. So alternate interior angles are congruent. What if we had alternate exterior angles? So we need two angles that are formed on the exterior of our lines here. So alternate exterior could be this angle here. Alternate means it needs to be on the other side of the transversal. And it is exterior, so it is on the outside of those two lines. It's that one here. Well, look at that. Those are congruent. If we switch over to the other two alternate exterior angles, likewise, those two are congruent. So alternate interior angles are congruent. Alternate exterior angles are congruent. What about if we have corresponding angles? We just have corresponding and same side interior. So let's see here. We have our two parallel lines still cut by that transversal still. Same side interior would be this 120.4 and this 59.6. Well, those obviously aren't congruent. They're not the same, but there is a relationship between them. If I were to slide this angle up, and I were to just slide it up here and move it there, well, notice it's the same measure, 59.6 and 59.6. So what's the relationship between this 59.6 and this 120.4? 59.6 plus 120.4, well, that equals 180 degrees. So these same side interior angles, those add up to 180 degrees. If we did it on the other side, if we looked at the other two same side interior angles, 59.6 plus 120.4, those also add up to 180. So same side interior angles add up to 180, which means they are supplementary. And the last relationship we have is corresponding angles. And if you were able to look at this diagram and kind of diagnose what's going on pretty quickly, you can see exactly where we're going to end up. So let's see this real quick. Corresponding is just, if it is in this spot in this diagram, we just slide our eyes down to that spot, and we notice those are the same measure. Corresponding to this angle up here would be this one here. They're the same measure. So corresponding angles are also congruent. Those patterns hold true every single time we have parallel lines cut by a transversal. It's a rule.